In this video, we will talk about the linked list. Linked list is a data structure which can grow or shrink in a size according to the requirement. So, what I want to say is, linked list is a link. When we declare a linked list, then declare does not need a successive memories or a consecutive memory location to store the element. For example, if we define an array, we have an array which take the memory space which are in a linear fashion. For example, if the memory address starts with the 100, then the second element will be presented 104 and so on. And second element can be found out by just adding plus 1 to the previous index. Okay, but in we can have the case, for example, we have a memory and we are requirement some for example we require to store the 10 elements. Okay, but we do not have the consecutive space to store the 10 elements. So two elements can be stored here, but we have something filled here, and we can then have space of one element here, then we have some filled space. So we do not have some, we have consecutive space. So through the help of the linked list, we can simply define a linked list. For example, here we can place 10, then this 10 will contain a pointer. This will contain a pointer which will point to the next element. Next element, say if next element is 20 and is present here, so it will point to this location. This element also will contain the pointer and this will point to the next element. So it will point to the here. Okay. So we do not require the consecutive address space to store the linked list. So in this way, we linked lists are very useful. Okay, and one more thing in linked list is that, for example, we have elements like 10, 20, 30. Okay, we have three elements. So we will have pointer to our first element, which is called as head. Okay, now let's say we want to place one more element. I have one more element, that's if let's say 5. So we want to place it at the beginning of the linked list. That is, it should be the first element. If we would have an array, then what it would be, let's say we have an array 10, 30, 40 and so on, and if we want to insert an element, so what we need to do is we have to shift all the element to the next position, and then this position will be empty. So this will become 10, this will become 20, this will become 30, and then it 5 can come here. So this is the order of an operation to shift all the element to its right position. Okay, so it becomes order of an operation when we want to insert at beginning. Okay, but in the linked list, in the linked list, we can simply do it in order of one. We just have to uh, point this pointer to this and head pointer to this. Simply, it is only order of one operation. Okay, in this way, a linked list is very useful. Uh, and one more thing is that when we use array, then when we declare array, for example this, then we have to declare here the size. For example, if we want to place the 10 element, then we have to write it here that we want to store the 10 element. It can be possible that at the beginning we are only using two elements only. We have only two elements, but this part of the array is empty. We are not utilizing. So this become wasteful. Okay, so this become wasteful. But in the linked list we can grow and shrink according to according to our use. Let's say if we require only two elements, then we will define only two element in the linked list, and we will require more element, then we can simply create one element and we simply then insert it to the end of the linked list, or beginning of the linked list. Okay, or anywhere in the where we want to insert. So in this way, it also useful because it do not waste, it does not waste the memory. And let's say if we have declared the 10 elements only, and in the future we need to store let's say 15 elements. So what we will do, we need to delete this array, and we have to need redeclare all the we need to redeclare the array of size 20, and we need to copy all these 10 element to this array, and then the all the new elements would also be inserted here. So this is also a very big problem with the array. Okay, because it does not grow according to our use. We have to declare the size before at the time of declaration only. But in the linked list we can grow as as we will have the new elements. Okay, and we can also delete the elements if we do not use them. Okay, so yeah, so in this way uh, linked list works. So how do we define the linked list? Okay, so I said here that we have two entries here. One is element, that is the data, it is the data that we want to store, and one is pointer, it is a pointer which point to the next element. Okay, so we need to fill in a linked list. So it is a simple linked list which is called the singly linked list. Singly linked list, it is called singly linked list. So we need to make a struct, for example node. Generally, uh, each element in the linked list we call it as a node. So a node contains two fields. One is data and one is address to the next node or the next element. So it will be the pointer to the next element. Or let's say next element, it is the next element. So we will declare the variable that makes sense, that is next. Okay, so it will be our structure for a linked list node, a single element. Okay, so in linked list we have operation like insertion. If we want to insert some element at any position, one is deletion operation if we want to delete some element. Okay, these two elements is important, and we will discuss the insertion and deletion of the code in the next lecture. Okay, yeah.